Alright, you guys, so let's go ahead and get started here with lesson 5.3 to solving systems of equations. Goal in this case is that students can find the solution of the systems of equations by elimination. There are other methods like substitution and graphing, but I will be focusing on elimination. If you have vocab terms here is having one solution, no solution, or infinite solutions. And this is just talks about if we were to graph our equations here, we could either determine if we have one solution based on the point they intersect, no solution meaning you have parallel lines, and infinite solutions when you have one line on top of the other. So like I said, guys, you guys can actually graph this. And if your graph appears to be, for example, two lines that intersect, then your solution would be the point that crosses between them. No solution in this case would be determined by two parallel lines. Two parallel lines are lines that don't connect. And infinite solutions would be, for example, let's say having this line and then having this another line that crosses it exactly on top of it. So they're basically equal to each other. All right, so that would be infinite amount of solutions when you have the equation equal to itself. No solution when it's parallel, one solution when it crosses at one given point. So let's go ahead and get started here, guys. And once again, I will be showing you guys this through elimination. So in this case, guys, it says find the solution of the system. So whenever we're trying to solve for these systems in this case, we do have two different variables. Goal in this case is to first solve for one through process of elimination, then substitute to find the other one. So goal in this case, guys, once again, is whenever we're doing elimination, we actually want to go ahead and eliminate one of the variables. If we take a look at this here, I have x's and I have y's, and then we have our constants. In this case, I could actually identify that both of the 7's here, or the y's, they're actually opposites of each other. So whenever you're doing elimination here, you're basically going to be canceling out what you can. In this case, this one's already given to us. So I'm actually going to go ahead and cancel these out. And I'm going to go ahead and combine the x's and the constant. So by combining, I would actually be adding these two. So a 2x plus 5x is 7x equal to negative 5 plus 12 is a positive 7. So next step in this case for us to solve for x here is I'm going to go ahead and divide by 7 on both sides. And x in this case is going to equal a 1. So we already found x. Now we just have to find y. So in this case, guys, in order for us to find y, we're actually going to do substitution. So to find y, substitute x. All right. So it doesn't matter which one I choose, guys, that they're both going to give me the same solution. So I'll actually just do the top one. So then I have a 2 times a 1 plus a 7y equal to negative 5. All right. 2 times a 1 is a 2. Bring everything else down. Now, goal in this case is to solve for y. So I'm going to go ahead and actually move this 2 to the other side. And let me just draw a line here just so I could tell where both of my sides are. So I will be subtracting a 2, doing the opposite, and I do it to both sides. And that gives me a 7y equals negative 5 minus a 2 is a negative 7. Final step in this case, guys, is to divide by a 7. So y in this case equals a negative 1. So the solution of the system is x equals 1 and y equals negative 1. All right. So it would be basically our point 1, negative 1. All right. So let's go ahead and take a look at the next one, guys. And once again, same thing here. And not all the cases, guys, it's going to actually be pretty where you're going to have opposites y's or opposites x. So you do have to change them. So I do have a 3x and an x. I have an 8y and a negative 4y. In this case, I will once again go for the y's just because one's positive, one's negative already. So in this case, guys, I'm actually going to go ahead and change this bottom. So I need to change this negative 4y or 4y into an 8. So what I have to do here is I'm actually going to go ahead and multiply everything by a 2. Multiply everything by a 2. And in that case, that would actually give me now a negative 8 there. So let me write that on the bottom. Or let me actually write this on the side. So 2 times an x is a 2x. 2 times a negative 4y is a negative 8y. And then 2 times a 5 is 10. And I'll just be bringing this one to the other side. 3x plus 8y equals 15. Now, in this case, guys, these are now opposites of each other, which means that we are going to cancel them. So these cancel. And now I have a 3x plus a 2x is a 5x. And then a 15 plus 10 is 25. All right. Final step in this case, guys, if we want to go ahead and solve for x here, I'm going to go ahead and divide by 5 on both sides. So x in this case equals a 5. So we found x here, guys. Now we need to find y. Once again, guys, it doesn't matter which one I choose, as long as you do the original version of the equation, not the changed one. So I'm actually going to go ahead and use this one here to solve for y. So solve for y here. So we're going to go ahead and substitute. X in this case, guys, that's a 5 minus 4y equal to a 5. All right. So next step in this case, guys, here is to subtract a 5 to both sides, giving me a negative 4y equal to a 0. All right, next step here is to divide both sides by a negative 4. So y in this case, 0 divided by a negative 4, that's going to give us y equal to a 0. So the solution here would be the point 5, 0. All right, that would be our solution. All right, so that's solving example 2. Now let's go ahead and take a look at this one here. Example 3 in this case says, is the point 2, 3 a solution of the system? In this case, guys, if they're giving you a point and you want to see if it's a solution to the system, what we want to go ahead and do here is we actually want to go ahead and substitute this value into our equations, into both of them. And if it works for both of them, then it's a solution. If it doesn't, if it only works for one, then it's not a solution. Because if something has to be a solution, it has to be working for both. So starting off with the first one, I'll do it in purple here. So for this one, this is x and that's y. So then that's a negative 2 plus 4 times 3 equals a negative 9. So negative 2 plus 4 times 3 is 12 equal to a negative 9. So negative 4 plus a 12 is a 10 equal to a negative 9. So this one here, it doesn't work. It's not giving me a solution there. So automatically right there, I can say, you know what? This is not a solution to it. But we can check with the other one. And I'll go ahead and do that one in green. And once again, y is 3 equal to negative 2 times 2 plus 6. All right. So 3 equals negative 2 times 2 is 4, negative 4, plus 6. So that gives us 3 equal to a 2. Once again, no solution. So in this case, we have no solution. Or the point in this case is not a solution to the equation. There's no solution.